Great. Okay, so we are doing complex numbers today. So you're all familiar with solving something like x squared equals to 25. So you would just go x equals plus or minus square root of 25. And you've got two real solutions, which is plus or minus 5. Okay, but let's say if you had x squared equals negative 25. So now if you try and put this into your calculator won't like it. It doesn't like to square root a negative number. So just like all numbers, you have to understand that all numbers are something that we have defined. So let's say by definition, there is a number such that, okay, let's call this number I. And if you square that number, it's actually negative 1. So this is by definition. So we have defined, by the way, I is not a variable, it's a number. So we have to find a number so that if you square this number, the result is negative 1. Okay, so then we might be able to do square root of a negative number. So if I squared is equal to negative 1, then x is going to be plus or minus 25i squared. Okay, so then my result is 5i plus or minus 5i. So what we have here is an imaginary number. So it's not something that we see naturally occurring. So these are called imaginary numbers. Okay, so imaginary numbers have the I as an attachment to it. Okay, so just remember it's not a variable. I doesn't hold a value. It just goes with the number to tell you that it is imaginary. Okay, so it's not real. Now, complex numbers. So complex number, okay, has two parts to it. So it's got a real part like a normal number, 1, 2, 3, 4, 5, or negatives. And then it's got an imaginary part to it, which has the I. So we define, or we use the letter Z to represent complex numbers. And you've got x plus iy. So this is called the real part. Okay, it doesn't have an I to it. And the imaginary part is the y. So not the I, just the y is the imaginary part. Okay, so for example, if I wanted to define what is the real part of z, so I would say, let's say, what is real part of z? Then I'd say it's x. What is imaginary part of z? And that would be y. So when I say re bracket z, so I mean real part of z. When I write down im bracket z, I mean imaginary part of z. Okay, so what we can do is we can sketch them on a plane, not a Cartesian plane. This is called an Argand plane, where you've got an imaginary axis. And I'll just show you how it works. So you've got, this is our real axis. Okay, so, and this is our imaginary axis. Okay, so if I had to sketch something, like say z is equal to 3 plus 2i. So remember, the 3, the real number, is your real part. And this here is your imaginary part. So I'm going to be plotting the real part on the real axis. So 1, 2, 3, 3 across. And then on the imaginary axis, it's 2 high. So this here is my complex number z, 3 plus 2i. Okay, so now this diagram where you've got the imaginary and the real axis is called the Argand plane. Now, sometimes we might have equations involving imaginary parts and real parts, and I'll quickly show you how you might be able to solve something like that. So let's say you have, let's say you have 4x plus 5yi, and it's equal to another complex number, which is perhaps 8 plus 20i. Now, in a situation like this, what you have to understand is if you've got two complex numbers that are equal to each other, so this must be equal to this, okay? So the real parts are equal to each other and the imaginary parts are equal to each other, okay? So I can work out x and y using that. So 4x is equal to 8, which means x is equal to 2, and 5y is equal to 20, which means y is equal to 4. So when you have an equation like this, we equate the real parts together and we equate the imaginary parts together to work out the variables. Okay. Now, so today's main lesson is the operations on complex numbers. So this is the most crucial bit. You can actually do most of these things on a graphics calculator. And for that reason, in the real assessment, they don't give you just numbers. So they might just put in a K or something, or something like that to make it a little bit difficult. But first and foremost, when we're trying to learn it, it's ideal that we learn the basics using real numbers, and then you can apply it to put it when you put in constants. So U is this complex number here, 3 plus 4i, and V is another complex number, 5 minus 2i. So when you're adding them, we're actually just doing simple algebra. So the imaginary parts are like, and the real parts are like. Okay, so when I add them, so I'm gonna just add like you do with algebra, although they're not variables, but they are like. So what you do is you combine the real parts together. 3 plus 5 is 8, and 4i take away 2i is plus 2i. So that's how we add complex numbers. So combine real parts and combine imaginary parts. Now, so when you're subtracting, it's the same idea again. You're going to do, you take away v, so 3 plus 4i, take away, and the whole thing goes in brackets. So 3 plus 4i, take away 5 plus 2i, and you do the same thing again. So 3 take away 5 is going to be negative 2, and 4i plus 2i will be 6i. So it's the same thing about combining real parts and imaginary parts together. So this is how you add and subtract imaginary complex numbers. Now let's look at multiplying. So multiplying, u times v. So let's write down 3 plus 4i, 5 minus 2i. Okay, so when you're multiplying, again, we just do what we do with algebra. So each term in the first bracket is multiplied by each term in the second bracket. So 3 times 5 is 15. 3 times, just show you the arrow mark, so 3 times negative 2i is going to be negative 6. Oops, I think just go back to the usual color. So 3 times negative 2i will be negative 6i. Now moving on, I've done multiplying 3 by all the terms in the second bracket. So I move on to 4i, so times by 5, and then times by negative 2i. So that's going to be 20i. And next one, it's 8i squared. Now this is where the difference comes in. Now, remember, by definition, we talked about I squared is negative 1, okay? So that's what we need to put in here. Okay, so I squared is negative 1, so I'm going to replace I squared with negative 1. So I've got 15. Combining these like terms, that becomes plus 14i. and minus 8 times negative 1, that's positive 8. And so the final result, now I'm combining the real parts, 15 plus 8 is 23 plus 14i, and that's the final result. Okay, now I'm going to move on to the next part. So when you see a line, we have seen this when we were doing surds, and it's called conjugate of. So this is the conjugate of u. Now, just like we did with the surds, what we do is we change the sign of the imaginary part. So in that one, we changed the sign of the surd. Okay, so here you have the 4i, so I'm gonna change that to negative 4i. So what I will have here is, so conjugate of u will be 3 minus 4i. Okay, and conjugate of v, again, I'm changing the minus 2i, so changing the sign, it's going to be positive 2i. Okay, now the reason we need the conjugates is, again, because it's what we do with division. So the whole point of division with complex numbers is we would like to get rid of the complex number, the imaginary part, in the denominator. We don't like to have imaginary parts in the denominator. And so what we do is, so u over v, so you've got 3 plus 4i over 5 minus 2i. So what we do is we multiply by the conjugate over the conjugate, so 5 plus 2i over 5 plus 2i, so the conjugate of the denominator, I should say. So now down below, I'll do the denominator first. So we have a situation of a minus b times a plus b, so that's going to be difference of squares, so it's 5 squared minus 2i squared. Okay, and the numerator, so I'll just do what we did with the multiplication earlier. So 3 times 5, and then 3 times 2i, and then 4i times 5, and then 4i times 2i. And then we can simplify if need be. So let's just do that. So 3 times 5 is 15. And 3 times 2i is 6i. Then 4i times 5 is going to be 20i. And then 4i times 2i will be positive 8i squared. So then we will simplify this. I squared is negative 1, remember? So it's going to be 15, take away 8. And then 6i plus 20i will be 26i. And down below, that's going to be 25. Take away 4i squared. Now simplifying this a little bit more, so 15 take away 8 is going to be 7 plus 26i, and in my denominator 25 take away 4i squared. Remember, I squared is negative 1, so that's 25 plus 4, which becomes 29, and we like to write it in two separate parts, 7 over 29 plus 26 over 29i. Okay, so this is what we have for today. So you're just to summarize again what we have learned. So by definition, I squared is negative 1. So if you're square rooting a negative number, we replace negative 1 with I squared, and then we square root. So a complex number has two parts, real part and imaginary part. When you sketch them on a plane with the imaginary axis and real axis, it's called the Argand plane. And we did the operations. So when you're adding or subtracting, you just combine the real parts together and the imaginary parts together. When you multiply out, just like normal, you multiply it out, except I squared is equal to negative 1. And when you're dividing, we multiply by the conjugate of the denominator over the conjugate of the denominator, and we write it separately into two parts where you've got the real part and the imaginary part. So there we have it. That's the lesson for today. In